So yeah, I'm partly a little bit intimidated by people that wear a Python t-shirt in this audience. Actually, yeah.
It's not me.
So a little warning, I'm actually, I just code with Python since 3 years or something like that. So I'm considering myself a Pythonist, but I'm far away from being like the guru or something like that, okay? So, who is standing in front of you? I'm Yves. I'm a technical product manager at VMware. Come to me afterwards if you want to know what a technical product manager is. I'm a converted networking guy, so I was doing a lot of work on networks. I was a network consultant way in the past. I spent 7 years as a system engineer at Cisco, and then since 3 years I'm at VMware, and I go down the whole cloud automation and config management path. I'm in a business unit that is carrying about a product called NSX, which is our network virtualization product. So I'm speaking to an API, and that API creates virtual networks that you can patch VMs to, or in my case, I'm also caring about containers that I patch into these virtual networks. And why Ansible? Because first of all, you need to install the stuff, and Ansible is the perfect tool for it. Ansible is also perfect to install other things like OpenStack, etc. that I care about. I'm actually also running the OpenStack Munich Meetup group. And I'm a co-organizer for this meetup group. And Ansible is, as an example, also used in one of our OpenStack products. Now, why would you consider developing your own modules? There is a lot of built-in tooling in Ansible, let's call it that way. You can use command and shell scripts and shell out to something, raw, etc. All those things to do stuff. But at the end, then to really make your playbooks idempotent with all those strange, not like file operation stuff and not package management stuff, it can get quite messy, right? And then you catch yourself by doing things like skipping on errors, and then basically you run your playbook and it's full of errors that happen, but you say, yeah, that's expected, so that's why I'm skipping it. And I don't like that, right? I don't like red messages coming up just in regular operations. So you need to somehow catch what is normal, what is not normal, what is and so you need to build in a lot of conditions, right? And those conditions are hard to do in like if you hack around just with commands. So that's my main reason to use modules. And of course also I had to interact with our API, and so I'm using the local host as my API client, and then I send stuff to an API and I automate everything using Ansible talking to a single API. And there is no easy ready to use stuff for that, so I needed to build my own modules. I am also using CLI command tools like the OVF tool to deploy VMs in vCenter. What else do I have on that slide that I wanted to say? That's basically it, right? So even if you use CLI commands, it's great to use a Python-based module to actually catch if you have a lot of stuff coming out of standard out, right? If you don't have like clear indication of what is a failure or not, and you actually need to read through what this standard out of the command gives you, you also should rather build your own module instead of trying to hack around things in your playbook. Okay, why using Python to develop the modules? So first of all, you can write your modules in any language you want, right? You can use C, you can use Perl if you want, right? You can use any kind of language, Go, Ruby. As long as, and that's taken directly out of the documentation, as long as it's able to implement file I/O, and as long as you are able to write JSON formatted output to standard out, because your module will have to exit JSON formatted code, else things go wrong, right? Else you don't get the output correctly, and your module's task actually doesn't complete. right? So if you use a shell script as an example, you need to either pass it through JSON or to do fancy things like build your string with spaces between, etc., so that it looks like JSON. So why am I using Python? First of all, I like the language, and there is a lot of stuff you can just read and learn from, right? Ansible itself is written in Python, so all the core modules are written in Python. You can just look at them and learn from them. It's really easy to use, and there is a lot of built-in tool set also if you build Python based modules that you don't get if you build it or use it in a different language. But yeah, of course you can also use other languages. The most often used other language is shell scripting, because you can just reuse whatever you have in your shell script and adapt it to be a Python module, an Ansible module. Okay, let's get started. First few bits of knowledge is how do you actually call your module. This is one of the examples on how to call it. If you name a task here and then you put just test_module, what it actually will do is it will search for that module in multiple locations. The first location it looks at is whatever you pass with the Ansible library environment variable, or what you pass with the module pass option when you call Ansible -playbook and run your playbook. Yes, you can do that. You can put it in any place. It will also, of course, look in its core library in the installation path. Now, what I usually do is I put it into the library path on your top level module or on your role. For me, that's the most natural place to put it. If I at some point want to upstream it, of course, to Ansible itself, then I need to put it somewhere else. But if I just want to distribute my whole playbook with all the library and all the stuff, the best place to put it is actually here in the library path. So it will always search first for whatever is in /library alongside your top level playbook. And again, it's then really easy to distribute it. Just put it on a Git and that's it. Okay, you always get started with this boilerplate code, which is you have your main, and then you create your module from that class, and we will talk a lot about those inputs in a little while. And then you have this magic from Ansible module utils basic import star. Ooh, what's that? That's ugly. First of all, why is there an import statement down here and not up here, right? That's like against all rules. And why are you importing star? That's also, that's not something we are supposed to do. So yeah, just get used to it. That's actually what you do if you develop your module, but this is not the code that gets executed. What actually gets executed, as you can see here, is generated code. So Ansible takes that module that you have, it will then import this whole module there and put it into the right place. I have screenshots of that in the next slide. So it actually inserts roughly 1,600 lines of code into a final script that it copies over to the target system, and then it executes that Python script on the target system. Right? So as you can see here, this is the put. In my case, it's actually putting it to the same local host, right? But you usually would copy it to your remote host that does the execution, and then it executes whatever your Python path is or your Python binary is, and then the file that it generated. And this is what it actually generates. So here's your main that we had, and from here on it's actually putting this 1,600 lines of code into a huge Python script, and that's just one example where you actually have the class definition of Ansible module itself. And then at the bottom of it, down here, you actually have your main that gets called, and that goes back up and then calls your main that you defined in your module, right? And so that's why in your module code itself you put the from at that place. It's basically to reformat it into that script that actually gets executed. Okay, so let's have a look at the Ansible module class and the instantiation of that module object up there. So we have a argument spec, and this argument spec is what you then pass values to here in your test module. You put those variables in, and those get populated into those parameters in the argument spec. So you have keywords down there like required equals true. That's clear. It's a required parameter. So if you don't pass it, Ansible would actually shout at you and saying you didn't pass that mandatory variable. Then there is an interesting one, which is no log equals true. So usually if you look into the logs, you will see all the variables that get passed to the module. Now, if you want to put passwords in there, or I don't know, keys or stuff you don't want to share, you put this no log equals true, and actually Ansible will not put it into the logs. It will just put star 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 in there so that you actually can't see it. Then with choices, in this case true or false, it could be any other choice. It could be choice 1, 2, 3, 4 or whatever string. You can put, that's actually a mandatory variable, but you have to choose from one of those, right? You can't put blah in there. It has to be true or false. In this case, funny enough, it also combines two things. So it has to be true and false. In this case, it also has to be a Boolean. But that's just a coincidence, right? If you would have string 1, 2, 3, 4, then you wouldn't really enforce also the type, which you do down there, but we have that later. Then here is a completely optional variable. It's not enforced by anything. Then those variables are checked for existence later. We'll talk about that later down here with the required, one-off, and mutually exclusive. Then this one has a default value, so you can pass value to it, and if you don't pass a value to it, it's still present and its value is blah. Okay? Then you have a variable with a strict type here, which means it has to be a Boolean. If you pass anything else, then it's going to fail. And here is one with an alias. So actually that variable, you can call it with optional var with alias or with whatever, right? You can pass whatever. That's what you see down here. Whatever has value 5. Okay, and then required one-off means I am requiring the user to pass optional variable to all three, and no matter which one of them is present, I'll continue. If both are missing, then I'll shout at the user. And then mutually exclusive just says one of those two has to, well, it can either be one or the other, it can't be both, right? So if you combine those required one-off and mutually exclusive, you can enforce that the user has to pass one of those two, but not both. Okay? So how do you call then, or how do you get the value out of the variable? Later on, you can just say module params, and then you take the key that is defined here, and then you get your value. And here you can output it with module exit JSON. We'll see exiting modules in the next slide. So this is how you can exit a module. You either say module exit JSON, and then you put changed equals true, and then you could put any kind of data after that. So you can put any kind of variable in there with any kind of data, and it's going to get passed down to the like the output of your module. And then you can call it by saying test module dot some data to return, and then you can get this value and use it somewhere else in your playbook. The other option is to exit with changed false. And here you see the first one said okay, changed 1, and the other one says okay, not changed. So if you checked for something and it didn't change, right, and you didn't apply any new changes, you exit with change equals false. In the other case, you exit with change equals true. And if something goes wrong, you can exit with module fail JSON, and then this message is mandatory. So you have to put in a message, and that can be a string, like in this case, or it can be some form of JSON formatted data to output to the console. Okay, so let's have a look at an example. I'm a running guy, right? I love to go running outside, but I'm actually not that resistant to cold, right? I actually don't like running if it gets below a certain temperature. So this code here is a module that will let Ansible decide for me if it's okay for me to go running or not. So I have two if statements here, which is if the temperature is above my threshold, it's fine, I'll go running. So I'll change my state, I'll stand up from my computer and go running. And in the other case, my threshold, it's below my threshold, so I keep my current state, I'll just sit there and do my computerish stuff. The code can be found here if you fancy looking at it. So here we have the code that actually calls the API. It uses the request library, and it calls the Open Weather Map API, which is like an open network of weather station, and then we'll ask for the temperature in the city that I pass, and my city is obviously Munich, and that's a default city. So up here again, if the temperature is above the threshold, I'll exit with change state true, right? I will change my state. Decision is run, Eve run. It is, and then that temperature in that city. So if I run it with a threshold of 5.5, actually I did that on Saturday, we had 3.27 degrees in Munich. So no, actually yeah, that was fine. In this case here, no, my threshold was not fine. Actually I mixed up those two screenshots here, but you get the concept, right? Easy going. So what happens if I have to catch an error? So we saw before we have this module fail JSON. In this case I have code that does a try except on the requests, and if I get a request exception, like I don't know, I couldn't reach the host name could not be resolved or whatever, I'll do a module fail JSON. And in the other case also, if I get a response status code that is not in the range of 200, which means I get a 200 OK, I will also fail my module and say, sorry, didn't work. There is a little subtlety here. I pass the module itself to this function to make sure that I can actually call module fail JSON. Right? That's why I pass the module over to the function. Okay, so that was all great, and I was using requests to do this API calls, and for me personally, that's the best way of doing it, to use some native Python library. But of course, you also might want to do things with OS commands that you call. So you would usually in Ansible use the command option and then send some OS command to find something out and then get the value, etc. You can very elegantly do that in your Python-based module with module run command, and then you put the CLI command up here and then all your CLI options, and then of course you can parameterize all those options. The response object will have two items. Whoop, what happened? Screensaver, okay. The response object will be a list of two items. 0 contains the response code of the command as an integer, so you want to have a 0 in there for a successful return. But if you have a command that gives you a lot of granularity of the things it returns, you can react on those exit codes. And the other one is you get the standard out of the command in list item number 1. and then you can do all sets of things with it, right? You can pass it with some parser like JSON loads that we will see in the next example. You can search within with find or sort, count, whatever you want to do with it. So we'll change the running or not running, that's the question code, to use curl instead of requests. And again, you can find the code here. So here what I do is, first of all, I will format my URL that I will send to curl then later on, and I parameterize this URL here with the format method, and then I do the run command, curl, get, and that URL. As easy as that. And then we'll send the request with curl, and if my curl result is not 0, I'll actually do a module fail JSON and exit. If the other option, I don't fail the command, I will take the data and convert it to a dictionary using JSON loads by accessing the command result with list item number 1. I take the temperature, and then I check if I get a response code of 200 or a positive response code, and if yes, if no, then I'll fail, and else I'll write the temperature into this variable, and I check the variable if it's below or beneath my threshold, and I have the same result I had before. So this is basically using curl to do exactly the same we had before. And with that you can use any kind of command. So a real world example, here's what I did to push an OVA to a vCenter environment. So with the OVF tool, I have the OVF tool running on my jump box somewhere, right? And with run command, I just pass all these crazy variables that I have to remember into the OVF tool. I run my module, and all this stuff is basically in my answer file, and so I don't have to remember all those crazy commands anymore, right? And I can implement good reaction to failures. In this case, if you look at the code, you can see all the details. In this case, I'm actually failing if after deploying the OVA, I don't get a response from the API after a certain amount of time. So I push the code, I say boot it up, and then I wait at some point for a positive response from my API, or I fail. Okay, so how do you debug your module? Usually the standard way of debugging Python code kind of is print, right? You put like print commands or print in multiple places, and then you look and standard out what your code gives you, what your variable is in that point in time. Unfortunately, with Ansible that won't work. So print won't print anything out to you, right? So I also had cases where you would even cause a traceback. Now in the later cases, now I tried it out on Saturday. You actually don't have a traceback, but you just don't see anything that you print. So in short, don't use print if you debug your module. What you do is you put it into some variable like this list here. Then you append to the list all the stuff you wanna know of, like what the state of your variable is, etc. And then when you exit the module, no matter if it's a fail or a normal exit, you place it in some variable. Like in this case, I placed it in debug out, and then you say here you register the output of this test module in the test module out variable, and then here you want to print out the debug, this variable test module out, debug out, which will print out the content of this list, and then it will print this out. So I personally don't keep my debug statements or my debug logic in the code after it works, but you could also keep it in for the sake of other people debugging your code at some point. I personally take it out, right? Okay, and what is this support check mode about? You might have seen it in earlier slide. There is a module option there called support check mode. You can run the Ansible playbook in check mode, and then actually what it expects to do is to only check the state but don't apply any change if the state would have to be changed, right? And if you put it to false, or if you leave this completely out and you call your playbook with the check, with a -- check, then Ansible will just skip this task that calls your module, because you don't support check mode, so it will just not do anything with this task. It will not try this task, it will skip over it, right? So what you have to do if you really want to support check mode with your module is you have to put that to true, and then what you would do is you would have to put in your logic the code that actually implements a check mode. So in this case, if temperature is above threshold, and if module check mode, which would be false or true, if that's true, then exit and say I would have changed something, but I'm in a check mode, right? And with that, you can basically output at and do your more of a kind of like a compliance checks on your configuration instead of really changing something in your configuration. Okay, one little last thing, inline documentation. You are expected to put inline documentation in your module if you want to upstream it at some point. There are other rules that you need to conform to if you want to upstream your module, but having a documentation inline is actually the most important one, because Ansible itself is taking that and is building the documentation on their website. So like if you go to the modules documentation on ansible.com, it's all generated out of the inline documentation, and you can just go to that link to see how it would look like, and there are examples, or you can just peek at other people's code and find out how this documentation should look like. And there are also people that already build WebDoc generators for this inline documentation. So it's actually a good idea to put your documentation in there. I didn't do that on time yet, so I'm one of those bad guys that still has that on his to-do list. And one last thing before I go to questions: if you use a Mac like myself, you might run into this problem if you import modules. This is because on your Mac your path to the Python binary is somewhere else than in USR bin Python. Now the easiest change is you just say USR bin end Python. However, if you look into the documentation, you will see that this is actually something you shouldn't do. It's an anti-pattern, so don't use that. What you are supposed to use is actually to, for those systems that need it, put the Ansible Python interpreter into your variables or into your hosts or whatever.
Why is that an anti-pattern?
I don't know. I don't know.
General lore and mystics.
I don't know.
Well, it's easy. The Zen of Python say be explicit, not implicit, and there you have an implicit lookup of your Python interpreter through the environment.
Okay. So let me try to repeat that for the recording. It's a rule in Python, or a best practice in Python, to be explicit instead of implicit. Right? Did I say that right? And so yeah. It's a best practice to not use USR bin end Python. I used that first, then I discussed that with some other module developer, and then he pointed me to some mailing lists entry where he said, look, they don't actually like that. Okay, good. Any more questions? Yeah.
When you define your module interface, is that checked before you start your playbook, or when it's actually time to run it?
When you define your module, you mean when you define the variables, etc. It's going to fail when it tries to do the task. Am I right? Yes, I'm right. Yeah. Okay.
Sorry, I'm not familiar at all with Ansible, but you mentioned this driver mode. I think it's
the check mode, yeah.
Check mode. what if you don't implement it? It will simply run anyway, or?
So the question was, what if you don't implement the check mode? So let's go back to the slide. So if somebody uses check mode when calling the, where's the check mode? If somebody uses this -- check here, and my module doesn't implement a check mode, it's going to be skipped. So the task using that module is going to be skipped by Ansible. So it will just not do anything about it. You will just have this skip message and then it will go on. Which will likely cause you to fail at some other point if you had to do something before or get some data before that you actually needed. And it's actually also some like general rule, if you want to upstream something, you should implement check mode. So they will kindly ask you to work on your code and implement a check mode.
You use the requests library, so that means if you just have an environment that is not as restricted and simple as yours, I would have to deploy the requests library to each and every target, not on my local machine.
Correct.
For this library, James Camerata said you should use get URL stuff. You have the get URL module and you could use everything from the get URL module directly in your Python code. I don't remember exactly how you get at that, but it looked rather simple.
Okay, so
he had the same problem in his talk, and so in general just avoid using Python libraries if you don't need to, because you have to deploy these Python libraries to all your targets.
Okay, let's repeat that for the recording. So Victor was just saying it's a best practice to use whatever Ansible gives you, like in the generated Python script, which you mentioned get URL would be or something like that would be a good thing to use instead of using the request library, because if you would use the request library, this means you have to have this request library installed with the right version on all your target systems. Yes, I agree. You should use as much built-in as possible to avoid failing your code because of missing dependencies. I mean, of course you could use Ansible to make sure your dependency is there before you run that module, but yes, I kind of agree.
And you use localhost, so it doesn't matter.
Exactly. Now with my stuff, right, I'm always interacting with an API, so I use localhost, so I use a single host of which state I really know of, right? I don't have like a zoo of hosts like you guys have. And so yeah, but I agree, it's better to use as much built-in as possible.
Strictly speaking, you can't even rely on having a fairly modern Python available.
Yes.
I think the minimum requirement for client machines is 2.6.
2.6 exactly, yeah. So yeah, that's also one of the rules. If you want to upstream a module, it has to run with versions as low as 2.6.
But currently they demand that it runs with 3 as well.
And they started to demand that it runs with 3 as well. Yes, I heard that too.
Not all of their modules do that.
Yeah. So I took a very easy pass to that. I didn't upstream them yet. So they are on a VMware GitHub location, and so it's whoever wants to use it is free to take it from there. At some point I will have to and want to make sure that I get that upstreamed, and then I will run through all these hoops. And certainly get shouted at for some ugly code at some point also.
What is the best way to automate testing of this model? And not only model, but this model in some playbooks.
Okay, so the question is, what is the best way of doing automated testing? So Ansible gives you a module test library, let's call it, or a possibility to test your modules. And actually, if you want to upstream it, you have to use that tool to find if your module actually works or not. Now, in my case, it wouldn't help me. Because I'm interacting with an API of a product that expects also things, right? And expects a certain order that I have to do and certain value that I have to give it. So I'm always working in a larger environment, and I have to interact with an API. So for me, it's not that easy to just run it through this standard test and say my module is great, right?
Is it possible to include some mock-up stuff in the testing?
Yeah, it would be possible. I could build my own mock API server, something like that. Yeah, for sure. You could. Now, in this testing of the module itself, I don't know. I don't know. Does anybody know if the module test code, if you could generate a server or something like that?
I think they spin up a server, but I'm not sure. I haven't ever tried it.
I don't know. No, sorry.
Lazy guy as well.
Okay. So then,
Thank you.
Thank you.